In this session, we are solving problems from Fourier series. The problem is find Fourier series for the function f of x equal to x in the interval 0, 2 pi. We know Fourier series for the function. So first, the given information from the problem is given f of x equal to x in the interval 0 less than or equal to x less than or equal to 2 pi. Fourier series formula given by, we know f of x equal to a0 by 2 plus sigma n equal to 1 to infinity an cos nx plus bn sin nx. This is Fourier series expansion of the function f of x. Here a0 equal to 1 by pi integral here the interval is 0 to 2 pi. So in finding Fourier coefficients, limits 0 to 2 pi f of x dx. An equal to 1 by pi integral 0 to 2 pi f of x cos nx dx. Bn equal to 1 by pi integral 0 to 2 pi f of x sin nx dx. So if you find these three Fourier coefficients, if you substitute in this formula, you will get Fourier series expansion of the function f of x. Now we are going to determine these three Fourier coefficients. So to find a0, according to a0 formula, 1 by pi integral 0 to 2 pi f of x means x dx. Already we know integral x means x square by 2, limits 0 to 2 pi. By substituting upper limit in place of x 4 pi square minus lower limit 0. 2 pi cancel, remaining 2 pi. So a0 equal to 2 pi. To find an. To find an, formula is given by 1 by pi integral 0 to 2 pi f of x cos nx dx. Here f of x is x cos nx dx. Now to evaluate this integral, once observe, under the integral product of two functions, one of them is algebraic, another one is trigonometric function. So under the integral, if we have product of two functions, if one of them is algebraic and another one trigonometric or exponential, we go for generalized rule of by parts. So we have to take u and v. Take always algebraic as u, another one v. So to apply generalized rule of by parts, take u as x, v cos nx. U equal to x, v equal to cos nx. In the generalized rule of by parts, integral uv dx means uv1 minus u dash v2 plus u double dash v3, like that. We require for u derivatives. So u dash 1, u double dash 0. Here integrals, v1 means integral of v. So integral of cos is sin nx by n. v2, again integral of this, that is 1 by n constant. For sin, integration is minus cos nx by n. So minus cos nx by n square. So integration by parts formula, integral uv dx equal to uv1 minus u dash v2 plus u double dash v3 minus u triple dash v4 plus and so on, alternative signs. So to find an, 1 by pi integral x cos nx dx, limits are from 0 to 2 pi. Take this as u and this as v, so that 1 by pi integral uv dx equal to, apply by parts formula. Already we determined u dash, u double dash, all the symbols v1, v2. So keep this formula in mind, observe these symbols and note down values here. First term u v1, u x v1 sin nx by n, u into v1 minus u dash v2, u dash is 1, v2 minus cos nx by n square, already minus sign, so that becomes plus cos nx by n square, u v1 minus u dash v2, next term u double dash plus u double dash, but here u double dash 0, the formula, infinite formula stops. Limits are from 0 to 2 pi. Now we have to substitute the limits. Integration with respect to x over, in place of x, upper limit substitution. 2 pi into sine, in place of x 2 pi, that is 2n pi by n, plus cos, in place of x 2 pi, 2n pi by n square, upper limit substitution, minus of lower limit substitution, in place of x 0, 0 into this one 0, plus here cos 0, in place of x 0, so cos 0 by n square. Already we know identities, formulas, sin pi, sin n pi 0, sin 2n pi also 0. According to these formulas, 1 by pi, sin 2n pi, this value 0. So 0 into this whole term 0. Cos 2n pi value is 1. So 1 by n square minus cos 0 value 1. So 1 by n square. 1 by n square minus 1 by n square 0. Therefore, you got an equal to 0. Now, to find bn. To find bn, formula is 1 by pi integral 0 to 2 pi f of x sin nx dx. So, 1 by pi integral 0 to 2 pi. In our problem, f of x means x sin nx dx. Now we have to evaluate this integral. Under the integral, algebraic and trigonometric. That means we are going to follow generalized rule of by parts. So here u is algebraic, v is sine function. So according to these, bn equal to 1 by pi integral 0 to 2 pi x into sin nx dx. Here u is x, v is sin nx. So ux v equal to sin nx. For u, derivative is 1, u double dash 0. For v, integration v1. For sin, derivative is cos. Integration is minus cos nx by n square n. If you keep like this, actually you may get a doubt, confusion. Is it integral of sin is minus cos or cos? Clearly we know derivative of sin is cos, so integration minus cos. v2 equal to, for cos function, integration is sin, so minus sin nx by n square. Already n, one more n we will get. So once observe clearly integration, integral of cos nx by n, here minus sign, so minus 1 by n integral cos nx. Integration of cos is sin nx by n, so that we will get minus 1 by n square sin nx. Now apply the formula 1 by pi u v1 ux v1 minus cos nx by n, u into v1 minus u dash v2 plus u double dash. As it is 0, formula stops. Limits 0 to 2 pi. 1 by pi minus x into cos nx by n minus minus plus sin nx by n square. Limits 0 to 2 pi equal to 1 by pi. By substituting upper limit minus 2 pi cos 2n pi by n plus sin 2n pi by n square minus of lower limit substitution. In place of x 0, so 0 into this one 0. Sin 0, that is also 0, so lower limit substitution 0. 1 by pi. Clearly we know cos 2n pi 1, so that minus 2 pi by n. Sin 2n pi value 0. Pi cancel. Minus 2 by n. Therefore bn equal to minus 2 by n. We got from the problem, we got a naught equal to 2 pi, an equal to 0 and bn equal to minus 2 by n. Therefore Fourier series expansion for the function f of x is a naught by 2 plus sigma n equal to 1 to infinity an cos nx plus bn sin nx. This is the formula. Substitute. We got a naught equal to 2 pi. So 2 pi by 2. And an value 0. We got this value 0. So 0 into cos nx 0. N equal to 1 to infinity. Bn value minus 2 by n sin nx. So f of x means we know x. So Fourier series expansion for the function x is given by pi plus sigma n equal to 1 to infinity minus 2 by n sin nx equal to simply minus 2 sigma n equal to 1 to infinity sin nx by n. This is required Fourier series expansion of the function x in the interval 0 to 2 pi. This completes the problem solution.